In this video, we'll take what we've learned about demand and supply and put them together to talk about a market. And we'll say that a market is in equilibrium when quantity demanded equals quantity supplied, or the plans of buyers line up with the plans of sellers. So we can draw our downward sloping demand curve and our upward sloping supply curve, and you'll notice that there's a point where supply and demand intersect. And so at P star, or at our equilibrium price, quantity demanded and quantity supply equal to each other, and they equal the equilibrium market quantity. So at P star, and I'll use those stars to indicate equilibrium, quantity demanded is equal to quantity supplied is equal to the equilibrium market quantity. So we denote our equilibrium price and quantity as P star Q star. And there are three ways to find equilibrium. So if we're given demand and supply schedules, so remember that's the tables with price and the quantity demanded and quantity supplied at each price, we can find the price at which quantity demanded equals quantity supplied, and that is the equilibrium price and quantity. We can also find equilibrium graphically. So if we have a graph of supply and demand, we can ask, where did the curves intersect? And that's our equilibrium price and quantity. And then finally, we can find equilibrium algebraically. So if we have equations for demand and equations for supply, so these equations would relate price and quantity demanded and price and quantity supplied, then we can set quantity demanded and quantity supplied equal and solve for P star and Q star, which is essentially the same thing as saying we find their point of intersection. So let's do an example. And remember, with these examples, it's helpful to pause the video, try to work through the problem on your own, and then restart the video to check your work. Okay, so use the following equations for the supply and demand of hockey sticks to find the equilibrium price and quantity. So here we have price equals 50 minus 4QD, and P equals 10 plus 4QS, where P is the dollars per hockey stick and Q is millions of hockey sticks. Okay, so pause the video and try to work through this on your own. So here we're given two equations. We have our equation for demand and our equation for supply. And we have two equations and two unknowns, price and quantity. And we want to solve for the single price, P star, where quantity demanded and quantity supplied are equal, and that's going to be our equilibrium market quantity. So here we're given the demand and supply equation with P as a function of quantity demanded and P as a function of quantity supplied. And so both of these equations are P equals. So we can set the two equations equal to each other. So 50 minus 4Q, because remember, we're solving for where quantity demanded and quantity supplied are the same, so we can drop the demand and supply now, is equal to 10 plus 4Q. So we can add 4Q to each side. So 50 equals 10 plus 8Q, and we can subtract 10 from both sides. 40 equals 8Q, and we can divide both sides by 8. So Q star equals 5. So our equilibrium quantity is 5 million hockey sticks. And to find our equilibrium price, now we can take our equilibrium quantity and plug it back in either for quantity demanded or for quantity supplied. I'll show you that they should both give us the same price. So P is equal to 50 minus 4 times 5, or P is equal to 50 minus 20. Our equilibrium price should be $30 per hockey stick. If we use the supply equation, P equals 10 plus 4 times 5, which is 10 plus 20, or P star equals 30. So you can use either or. Because you've set the equations equal to each other, it should give you the same value. But our market equilibrium is P star of 30 and Q star of 5, or 5 million hockey sticks. One thing that you may also find helpful is graphing the lines. And so I think the easiest way to graph these lines is to think about, well, we have price on our vertical axis and quantity on our horizontal axis. And so typically, I always found the easiest way to graph a line was thinking about the y equals mx plus b form, where b was that y-intercept and m was the slope. So now the price is just kind of like our y variable and quantity is like our x variable. So here, 50, for our demand equation, 50 is going to be our price intercept, and there's going to be a slope of -4. And that horizontal intercept would be 50 divided by 4, or 12.5. So here's our demand curve. And we most of the time won't worry about the horizontal intercepts, but sometimes it's nice to put them on there just so that you can make sure that your equilibrium price and quantity makes sense. So for the supply curve, the 10 is our price intercept, and we have a slope of +4. And so the equilibrium point is a quantity of 5 and a price of 30. And just remember that quantity here is in millions. So now we want to talk about what happens if the plans of buyers and sellers do not align, or what if the price is not at the equilibrium price. So what if the market price, P, is higher than the equilibrium price? Well, if the price is higher than the equilibrium price, sellers are going to want to sell a lot. So the quantity supplied is going to be very high, but quantity demanded is going to be lower. So quantity supplied is going to be greater than quantity demanded. And when this happens, we call that excess supply. You may also hear it called surplus. And surplus just means excess. So here we have surplus goods and services. We're going to be talking about consumer surplus and producer surplus and economic surplus shortly. And so the reason I use excess supply is just so that you don't get this type of surplus of goods and services confused with consumer surplus and producer surplus, which is kind of an excess of well-being, if you will. So if there's an excess supply, what that means is producers have produced a bunch of these goods or services, but buyers aren't buying them. So there's a bunch of excess stuff on the shelves, and producers want to sell that. And if they're receiving this signal from buyers that they're not willing to buy at this price, then sellers are going to start to lower their price in order to sell all of these goods and services that are building up. So the price will naturally be pushed back down to the equilibrium price, P star. And this is what we call the invisible hand. And this is what Adam Smith mentioned in The Wealth of Nations, hundreds of years ago, that there's this invisible hand of the markets that is keeping things in line. So markets act in such a way that they're constantly moving back towards equilibrium. So now instead, let's talk about the case where the price is below the equilibrium price. So if the price is below the equilibrium price, at this low price, quantity demanded is going to be quite high. There are going to be lots of buyers willing and able to buy the good or service, and quantity supplied will be much lower. And so we have quantity demanded that's greater than quantity supplied, and we call that difference excess demand. And sometimes you'll hear this referred to as a shortage. And so if there are a lot of buyers willing to buy the product and very few sellers willing to sell, you're going to find long lines. And sellers are going to start to realize that they could probably be charging higher prices, and buyers are going to start to bid up the price because there are going to be people that are willing and able to pay more for this product. And so the price of the product will eventually be pushed up to the equilibrium price where quantity demanded is equal to quantity supplied, and the plans of buyers and sellers align. So one way that we use models in economics is to make predictions. So we're going to be using this model of demand and supply to make predictions about how different events or factors might affect markets. And so kind of the first step in determining how something is going to affect the equilibrium price and quantity is to think about, does this event affect supply, does it affect demand, or does it affect both supply and demand? Then you want to say, does it cause an increase in these curves or a decrease in these curves or no change? And then what effect is that going to have on price and quantity? So let's try some examples. Okay, so let's assume that new research comes out proving definitively that pizza causes heart disease. What happens to the equilibrium price and quantity in the market for pizza? So the first thing we want to do is label our supply and demand curves, and this is our market for pizza. So the next thing we want to do is say, okay, what is this event? We've got the research coming out that proves definitively that pizza causes heart disease. Is that going to affect supply? So plans of sellers, plans of buyers, or neither, or both? And research about the effects of eating pizza shouldn't affect how much sellers want to sell, but it might affect how much pizza consumers want to eat. So this would affect demand. And now we have to think about, is this going to cause buyers to want to eat more pizza regardless of the price, or less pizza at every price? And if there's a clear link between pizza and heart disease, we might assume that consumers, regardless of what they were previously paying for pizza, are going to want to consume less pizza at that price. So that's a shift to the left, or a decrease in demand. And so now we want to think about, how is that going to affect the equilibrium price and quantity? Well, originally, we had P star, Q star as our price and quantity. Now, that decrease in demand, the price has fallen, and so has the quantity. So the equilibrium price has decreased, and the equilibrium quantity has also decreased. So now let's add on. Now let's assume that in addition to the research that's come out proving that pizza definitively causes heart disease, that simultaneously the price of cheese has fallen. So now we have two events happening simultaneously. So we've already talked about how the first event would affect the market. Now we want to consider how the second event, which is happening concurrently with the first, is going to affect the market. And so cheese is the input. So if the price of cheese decreases, this should increase supply or shift supply to the right. So now our new market equilibrium is going to be at the intersection of D prime and S prime. And so the way I've drawn it here, it looks like that price has fallen even further and quantity hasn't changed from the original quantity. However, we can't be sure because we don't know by how much demand has shifted and how much supply has shifted. So we know that when supply increases, so if we only had a supply increase, we would have seen the price falling and quantity rising. But we don't just have a supply increase or a demand a decrease, we have both happening simultaneously. So what we need to do is think about adding the effects together. So overall, this is going to lead to a definite decrease in the price and an ambiguous effect on quantity. And it'll depend on whether that shift in supply was larger or that shift in demand was larger.